In this example, we're going to find the volume of the solid that's formed or bounded above by the surface z, a multivariable function, y times sine of x times y, and below by this region R. So we have a rectangular region R. Now, when we have a rectangular region, I always think it's helpful, even if we know what it looks like, to sketch it. So this is saying my x's are going from 1 to 2, and my y values are going from 0 to pi. So this is my region R here. And because my bounds are nice and straight, we don't have any issues with determining how or which order to integrate. So we have the option to set up this integral. I'm going to say the integral over R of y sine of x times y. That area, we can either write dx dy, or we can write dy dx. So we want to think about our integration first. So suppose I had written here dy dx. If this is dy dx, that means I'm going to integrate first with respect to y. Now, integrating this with respect to y, that means we only treat x as a constant. So we've got a product in our integrand that we have to deal with, and that makes it harder. That makes us think, hey, we might have to use integration by parts or u substitution. Oh my gosh, I don't want to deal with this problem. Therefore, if we think about setting this up and we have dx dy, well, then this y value is a constant, and we're just going to find the integral of sine, which is going to be negative cosine. So clearly, I hope you guys can see that putting dx first is going to make our job easier. Okay, so let's think about what our bounds are going to be. We just have that region. Since we said we were going to do x first, my x values are 1 to 2, so I'm going to have my integral x equals 1, x equals 2, dx, and then my other integral, that's going to be y equals 0 to y equals pi, and then I'll have my dy on the outside. All right, so again, just restating it, if we integrate with respect to x first, y is a constant, this is much easier for us to deal with. And so when you're doing these volume problems and you're given information and you have to set it up, if it's not given to you, you have to think about, well, what is the best choice to make and which order is going to work the best. All right, so let's jump into this, focusing on just the inside here. Integrating with respect to x, y is a constant. So if this was like a 3x in here, we would end up dividing by that 3 when we turned it into negative cosine. So this is, we're going to divide by y. So I've got my y values from 0 to pi, and I'm dealing with y times negative 1 over y cosine of xy. And that's evaluated from x equals 2 to x equals 1. Now, before we integrate, of course, we can simplify. We should notice that these y values are going to cancel. This negative can come in front. So I have negative the integral from 0 to pi of, my integrand is now cosine xy. We still need to evaluate from x equals 2 to x equals 1. So I'm plugging in this 2 and 1 for x. So now what I have in here, negative integral from 0 to pi, that leaves me with cosine 2 goes in for x. I have 2y minus cosine 1 goes in for x, 1y, or just y. So the y is still there. This 2 and 1 both went in for x. So now we need to integrate this with respect to y. We have the integral of a sum, which is the sum of the integrals, so I can just integrate each term. So that is negative the integral of cosine 2y, that's going to be 1/2 sine of 2y minus sine of y. And then, of course, we have our bounds, which were in terms of y. So I've got y equals pi and y equals 0. So 2 pi, pi, 0, 0, sine at pi and 0, those are all going to equal 0. I'm going to end up with negative 0. And the answer for this volume is 0. And you say, well, Ms. Stein, how can we have a volume of 0? Well, that's because part of the surface was above the x-axis, or the xy plane, I should say, and then the other portion of the surface was below the xy plane, and they canceled each other out. So this isn't technically a volume unless we are breaking it into pieces with regard to some line or some bound where we crossed this region in the xy plane. So what I'm going to do, I can't pull in a movable figure for you, but I made a figure on my computer and I took 2 screenshots of it. And so I want you to see, that's why we're getting 0, because we've got this volume that we've calculated above the rectangular region from 0 to 1 and 1 to 2 and 0 to pi. Again, we've got 1 to 2 and 0 to pi, and you can see it cuts through. So without finding that point or that line of intersection, we really can't find the actual, what we would say, volume. But this double integral has a value of 0. And I don't believe we have any situations where we have to find that line where it intersects through the curve in this class. So anyhow, I hope that makes sense. I encourage you to try and find some 3D graphing software. This is from monroecommunitycollege.edu graphing software. I just Google it. So monroecc.edu. You might be able to find it. Desmos does it as well, but I thought this one kind of made some nice pictures for us. So you see our region, and we have calculated that area between, or I'm sorry, the volume between the surface and the rectangular region. It just so happens in this that above and below, those are exactly equal and opposite, and they cancel out, and we get that this integral value is 0. Woohoo! Have fun, be safe out there. Email when you have questions.